Hello everyone. Welcome back to our course Fundamentals of Semiconductors. In the last previous classes, we came to know about the various types of semiconductors and their utilization in various circuits and how we can able to form a PN junction diode and what are the characteristics of PN junction diode in forward bias and reverse bias and how we can use this PN junction diode as a solar cell and what is the importance of Hall effect and what are the real-time applications of Hall effect. These have been completed in our course. Today we are going to start about the new concept, that is photodiode. So we already came to know that these semiconductors widely used in optoelectronic devices. So optoelectronic devices means whereas we can able to convert the optical energy into the electrical energy. In some cases we can also convert the electrical energy to the optical energy. So today's class is completely related to about the when or how we can able to convert the optical energy into a electrical energy. So solar cell also a kind of photodiode, but it works with the help of high brightness of solar light or some other light. Okay, but whereas in the case of pin diode, it is a completely different concept, and this pin diode we will use in reverse bias. Okay, so before knowing about the pin diode or avalanche photodiode or simply different types of photodiodes, let us know about the what is photodiode and how it works and what are the different types of photodiodes. So photodiodes. So simply in the name itself, photo means light. So the diode which detects the light and the diode which can transform the photon energy into the electrical energy can be known as photodetector. So these type of detectors widely used in various types of electronic devices where we can able to convert the optical signal into the electrical signal. Especially we all know that this optical fiber communication. So optical fiber communication, we know that in optical fiber communication, we are going to send the information as a form of optical pulses, so that the information can transform from one cellular tower to the another cellular tower, okay, as a form of light pulses, or one user to the another user. But at the end, by receiving this optical signal, that signal should be converted into the electrical signal. That electrical signal again converted into the whatever the analog signal or digital signal in a user language. So each and every optical fiber communication system, we need this photo detector. So photo detector means when light incident on this such detectors or devices, it can able to produce a electrical pulse. Okay. And what are the principle of these photodetectors? So there are two types of principles involved in these photodiodes. Number one is external photoelectric effect. Suppose when light strike on the surface of this material, this semiconductor material, then it can able to eject the electrons and leads to the flow of current in the circuit. So such kind of photoelectric effect is known as external photoelectric effect, and another one is internal photoelectric effect. Internal photoelectric effect is nothing but when light incident in the PN junction. Okay, so we are talking about the PN junctions only here. So when light incident on the PN junction, then it can able to create the electron hole pairs inside the PN junction and leads to the flow of current in the device. So that this effect is known as internal photoelectric effect. So all the diodes which we are going to learn in the coming soon, that pin diode or avalanche photodiode or some other photodiode, all are related to the internal photoelectric effect. That means when light strikes at the pin or PN junction, then it will able to generate the electron and hole pairs. That electron and hole pairs leads to the flow of current. So what is the use of these devices? Okay, so everywhere I said na, everywhere in a communication system or else sensors, many sensors. When light incident on the particular diode, automatically it will generate a electrical pulse. Suppose there, let us take any lift or some other coding scanners. Okay, when light strikes on a particular device, it will generate electrical pulse. Automatically that buzz will start. Okay, so buzzer will on automatically. So like this everywhere, when light incident on this PN junction, it leads to the generation of electrical pulses. Okay, so internal photoelectric effect mainly we are going to observe in the pin photodiode or PN junction photodiode and avalanche photodiode. So among the various types of photodiodes, today we are going to learn about the pin photodiode. Pin photodiode. Okay, so in this session we are going to know about the what is pin photodiode and how it is working, and what is the construction of pin photodiode, and what are the advantages and disadvantages of the pin photodiode, and applications of this pin photodiode. Okay, then introduction. So we all know that as early I said, so that pin photodiode is a diode which is consisting of PN junction. Okay, in addition to the PN junction, we have an extra layer, that is a region, that is intrinsic region. So the name itself we can able to know clearly, that is P, I and N. So P refers the P type material and N refers the N type material, that intrinsic region, whereas I is that refers the intrinsic region. So intrinsic region means where it doesn't have any free electrons or free charge carriers, it will act like a perfect insulator. So that we are going to sandwich a insulator in between the highly doped P type and N type material. So this pin diode or pin photodiode works in reverse bias only. So in forward bias, if you connect this pin diode, because of the highly intrinsic region, the net flow of current through the junction is 0 and it will act like a perfect switch. So that we won't use these pin photodiodes in forward bias. So pin photodiodes widely used in reverse bias only. Then how it works and how we can able to convert the optical pulse into the electrical pulse with the help of pin photodiode, we will see now. See, this is the symbol of the pin photodiode. So it is similar to the PN junction diode, but in addition to the PN junction diode symbol, we have two arrow marks towards the PN junction. So these two arrow marks indicates the incident photons. That means it will receive the optical energy and it can able to convert that optical energy into the electrical energy. And the schematic diagram we can able to see here, we have a highly doped P region, that's why I mentioned as P plus, and highly doped N region, in between large intrinsic region. Large intrinsic region. So this intrinsic region will act like a insulator. This is about the symbol of pin photodiode. And construction. So as I said, P type material is heavily doped. It has a huge amount of majority charge carrier, that is holes, and N type material is heavily doped and it has a more number of electrons. However, if they have, even though they have the huge amount of excess charge carriers, because of this intrinsic region, the flow of current is not possible from the P2 to N or N to P, even in the forward bias. And how it works? Okay, when light strikes in this PN junction pin diode, what happen means, this light, when light incident on this region, intrinsic region, automatically it will generate the electron hole pairs. We all know that while learning about the intrinsic and extrinsic semiconductors, we clearly came to know that whatever the semiconductor, either intrinsic or extrinsic, they will act like a pure insulators at zero absolute temperature. Then if you increase the temperature of the any semiconductor, there is a possibility of increasing the flow of current. So what is the reason behind this possibility of flow of current is because of the breaking of covalent bonds. So when we incident the light energy in the intrinsic region, it will absorb the energy, and whatever the electrons which are in valence band, okay, they will break up with the nucleus and they will come to the open place, that is conduction band, so that we can able to create huge amount of electron and hole pairs by incident the light energy in this spin photodiode. So this spin photodiode is a highly sensitive, highly light sensitive. Even a small amount of light energy is enough to create an electrical pulse in pin photodiode. Whereas in the case of solar cell, we need huge amount of lighting to convert the or to store the some amount of voltage. I said no, solar is a photovoltaic. Principle of solar cell is a photovoltaic effect. We can able to generate a small voltage, okay, by observing the solar energy. But whereas in the case of pin diode, what happened? So when light incident on this intrinsic region, it will break the covalent bonds, and electrons which are in valence band simply jumps to the conduction band. So when they jumps to the conduction band, they will become as a free electron. So all these electrons attracted towards the positive terminal, that is N side, and all the holes are attracted towards the P side because of the highly reverse bias. Highly reverse bias. So that when a small amount of photon energy incident on the intrinsic region also leads to the huge amount of current in the range of microamperes. So whenever light incident in on this intrinsic region, it will generate the charge carriers. Because of this, we can able to get the electrical pulse in the circuit. So when electrical pulse is there, that means based on the optical energy how much incident, and the electrical pulse energy also varies, so that simply we can able to convert these optical pulses into the electrical pulses. This electrical signals again we will convert it into the binary languages, and from that we can able to convert into the user language. So this is these diodes plays a major role in the communication system, whatever currently we are using. Okay. So this is all about working of pin photodiode. So very clear, right? So when light incident in the intrinsic region, it will generate the electron hole pairs. That electron hole pairs moving in the N-type and P-type region due to the high reverse bias voltage. So this pin photodiodes works in reverse bias only. Okay. And what are the applications or advantages? So it has a wide bandwidth and high response speed. So high response speed, that means I already said that these fin photodiodes are highly sensitive. A small amount of light also enough to get the electrical pulse and generate low noise. It won't generate much more noise, and high sensitivity of light and low sensitivity of temperature, and low cost, small size and long life. So low cost, it is like a PN junction, a simple PN junction. In between the PN junction, we are going to sandwich a small intrinsic region. That intrinsic region will act like a perfect insulator, but whereas in the reverse bias, when light strikes on this intrinsic region, that can able to create the charge carriers. That is only the simple concept, not much deeper required. Okay, very simple. When light incident on the intrinsic region, it we can able to generate the electron hole pairs. So that leads to the flow of current in the junction. And these are the references which I followed for this class. Okay, thank you for watching.